All right, so trigonometry. What trigonometry is the study of triangles. Okay, so this is really, really important for Math 3 and for any future classes that you'll have with math. This is the basic foundation that will cover and open up so many topics for you guys. So this is really, really important stuff. It's a little difficult, but just hang with me and shoot me an email if you got any questions on this stuff. So trig ratios, what we're talking about is these three different ratios pronounced sine, cosine, and tangent. Okay, these are our three ratios, and these are ways to find the sides of a triangle if you're given a degree and a side. So the sine of a triangle is the ratio of the leg opposite to that angle and the hypotenuse. So if we're looking for the sine of A right here, then we have A as our reference angle, right? A lot of times you'll see us put that arc. I'm going to put this thing called theta. It's a Greek letter representing angles, and all it is a circle with a line through it, okay? So that tells us that A is our reference angle. That theta says that this is what we're using. So the ratio of that leg opposite the angle and the hypotenuse. So the leg or the side that is opposite of this angle would be A. It's the one that it's not touching, right? So this would be the opposite side. C is obviously the hypotenuse because it's across from the right angle, and it's the longest side. And then B would be what we call the adjacent side, which you'll see that in just a second. But adjacent means next to. So if you remember my classroom, the classroom that is adjacent to mine is Miss Tyndall's classroom. But then you could say that the classroom that is opposite to mine would be across the hall, which is Grimes, right? So adjacent means touching. It means right next to. Tyndall's class is the classroom that touches mine, whereas Grimes is opposite. So adjacent is touching, opposite is across the way. And then hypotenuse will always be across from the right angle. So in this case, if we had the sine of A and we're using this, we do the opposite over the hypotenuse. So that will be, let's do something like A divided by B. Okay, so that would be the sine opposite divided by adjacent. But it can change, right? So instead of having our reference angle at A every single time, like it gave us here, we could have our reference angle at B, right? So in this case, now A would be the adjacent and B would be the opposite. Okay, so there we would have B. Oh, I'm sorry, it's over the hypotenuse. Why am I doing C? I apologize. I'm sure you've been wondering that for the past like 30 seconds. So A would be opposite over hypotenuse, which would be A over C. For the sine of B here, that would be the opposite over hypotenuse, which would be B over C. So you notice that we're using opposite over hypotenuse both times, but the actual reference will be different, and the sides that you use will be different depending on which angle we're given, depending on the reference angle that we're given. So for cosine, it's the exact same thing, except now we're going to use the adjacent and divide that by the hypotenuse, right? So we're always going to have C on the denominator for sine and cosine because that's a hypotenuse. And that does not change depending on our reference angle. So if we have A, and here is our reference angle right here, then we know that this is the opposite and that this is the adjacent. So if we're doing adjacent over hypotenuse, now it is B over C for cosine, and that's with reference angle A. When we do reference angle B, and I'm color coding these, we have B as the opposite and A as the adjacent. So side A, the adjacent, would be divided by the hypotenuse, which is C, right? And then lastly, we have tangent. Okay, so tangent is the opposite over the adjacent. Opposite divided by adjacent. So we're not using the hypotenuse at all. So if you look at tangent of A, and we use this theta, then the opposite, which goes up top, is A, and the adjacent, which goes on the bottom, is side B. All right, if we're looking at the tangent of B, using that blue reference angle, then opposite over adjacent would be B divided by A. So you see how the reciprocals there, they just flip depending on which reference angle you're using. Now, this is quite a lot, and some of you may be like, especially if you haven't seen this before, you may be thinking, holy cow, like you just threw out like 17 different words that I have no clue what they mean. I need to go back and watch that. That's perfectly fine. Go back and watch that. But here's a really great way to remember it, okay? So we have SOHCAHTOA. And some people think of like Sacagawea, and I'm like, no, it's SOHCAHTOA. I actually had a kid ask me once, like, isn't that the person that led Lewis and Clark across? And I was like, well, I'm glad you know your history, but no, not that name at all. So SOHCAHTOA is just an acronym representing sine equals opposite over hypotenuse, right? SOH. Cosine equals adjacent over hypotenuse, CAH. And tangent equals opposite over adjacent. If you have SOHCAHTOA, then you can do this. SOHCAHTOA, right? And if you have that, you can figure this out. The only other thing you'd have to worry about is the reference angles and just which one is opposite, which one's adjacent. Hypotenuse will always be the one across from the right angle. So looking at number 1, they've given us these ratios, and we're looking at A first. So I'm going to do a theta to say that A is our reference angle. That means that side 5 is our opposite. It's not touching this angle, right? That means that side 12 is our adjacent because it is touching this angle. And this one is your hypotenuse. Honestly, I would probably label the hypotenuse first. So then you just have to worry about adjacent and opposite. All right, so sine. We know that sine from SO is opposite over hypotenuse. So our opposite side, 5, divided by our hypotenuse, 13. And that's your answer. The cosine of A would be the adjacent over hypotenuse. This is CAH. Cosine equals adjacent over hypotenuse. So that's 12 over 13. And lastly, tangent, TOA. Tangent equals opposite over adjacent. So that will be 5 over 12. Okay, so now I'm going to do reference angle C in blue, and I will erase these other ones. So now we know that the hypotenuse stays the same, right? It's always opposite the right angle. And now if you look at this, the one that it's touching is 5, so that will be adjacent. And then your last one is the opposite. So you can there's a bunch of different ways that people will teach this, a bunch of different ways that students will learn it. You can kind of think of like like HA. That reference angle always touches H and A. And then whichever one is the hypotenuse is going to be opposite the right angle. It's also going to be the longest one. So that's a really easy way to remember it. Then you just know that the other one is the opposite. So you can do that if you'd like. So for sine of C, we're going to do the same thing, opposite over hypotenuse, which now is 12 over 13 instead of 5 over 13. Adjacent over hypotenuse will now be 5 over 13. And tangent will be flipped. So our opposite and adjacent flip. So now instead of 12 or 5 twelfths, we have 12 fifths. All right, so you can kind of see a little pattern here, hopefully, and you just see how those are reciprocals. Right, so the cosine of A is the same thing as the sine of C because you changed the opposite and adjacent. All right, for number 2, they don't give you a third side here. If only there was a formula we knew that could find that third side in a right triangle. Oh, wait, we have that. So Pythagorean theorem, they're just making you do a little bit of extra work here. 9 squared plus 12 squared equals C squared. 81 and 144 will be 225. And let's call that C squared, so then C would be 15. So that's 15, just a little bit of extra work there. We're going to do the exact same thing that we did last time. For W, I'm going to put my theta in there. And sometimes, like I said, you will see an arc. Most likely you'll see a theta. But if you see an arc, that's the reference angle that they're mentioning. So this is your hypotenuse. This is your adjacent because it's touching. And this is your opposite. So for sine, opposite over hypotenuse, that will be 12 over 15, which we need to simplify out to 4/5. For cosine, that will be adjacent over hypotenuse, 9 over 15, which both of those are divisible by 3, and that will be 3/5. Lastly, tangent will be opposite over adjacent, which would be 12 over 9, which simplifies out to 4/3. All right, so now we'll do blue, and we're looking at the reference angle x. Okay, so this now becomes your opposite. This now becomes your adjacent, and the hypotenuse stays the same. It doesn't change. So now you can see this pattern, but I really kind of want you to see it on the graph too, or on the figure. So opposite over hypotenuse for sine would be 9 over 15, which does simplify out to 3/5 like we've already got. Cosine would be adjacent over hypotenuse, 12 over 15, which simplifies out to 4/5. And tangent is opposite over adjacent, which is 9 over 12, which simplifies out to 3/4. So what we do here is we find missing sides with these trig ratios. So the way this works is, say you have sine, and you have sine equals an angle, or a sine of an angle equals opposite over hypotenuse. So they'll give you that angle and one of those sides, and we find the third one. So one thing that I just realized it didn't show you before is every single time, it's not just sine equals opposite over hypotenuse. There is an angle here. So the sine of this specific angle equals opposite over hypotenuse. And I don't think it mentioned that on the other side. Yeah, so there should really be like a little theta in here for these different angles. That's what we're talking about. So the three things that we will have is the theta, the angle, and then your two sides. But the thing is, they didn't just tell you, hey, find the sine of this. We have to figure out which one it is, whether it's sine, cosine, or tangent. So what? Right, so we need to label our reference angle, which is what we have here, 28 degrees. And then 19 would obviously be our hypotenuse, and now you just have to figure out what x is. Well, this other side over here is touching, so that's got to be adjacent. So this has got to be the opposite. So the two things that they gave you, you notice that the adjacent side is blank. There's nothing here. The two things that they gave you are the hypotenuse and the opposite. So we look up here and we try and figure out which ratio has hypotenuse and opposite, and that will be so, which is sine. So we set this up as sine of theta equals opposite over hypotenuse. And now we're just going to fill in the different things. So sine of theta is our angle, that's 28 degrees, equals opposite x over hypotenuse, 19. So if we're solving for x, all we have to do is multiply both sides by 19. So x will equal 19 times the sine of 28 degrees. And here's the thing, we are using degrees, so you need to go into your calculators and use degree